Hello everyone and welcome to another stream episode of No Orientation Programming. I'm Joe and today we will finish, hopefully, our commanding process. That's the plan for today. Oh, fine whiskey. Oh yes. Oh yes. Oh. Cheers. Fine. So, what do we want to do today? That is, we have merged the commanding process already lately. Nope. As you can see here, we have improved system commanding, improved and dominating. We added the following features: navigation, left right, start end, jump left, jump right. We have insertion now, deletion, history, insertion, skip if empty, skip if duplicate, remove code if not needed. If the number of history entries is set to 0, then we don't even have the history code compiled. So it's the footprint should be less in this case. We have navigation in the history and of course the buffer and history size configuration. So yes, and today we want to finish the process with 3 more things: the autocomplete and the command suggestion features, and a very common command. I want to have an internal command which is very common, that is the hex dump. Maybe write memory would be cool too. Message broadcast is not that important, but write memory could be useful in a lot of cases. So hex dump, read and write memory would be interesting. Should we call this thing hex dump, or how should we call this? Mem write, and maybe W, and then read memory. Mem read R. Maybe so hex dump would be the same as read memory, essentially. Or let's call it MW, MR, maybe, because these are very common commands. Okay, let's see. So I have started the autocomplete and the command suggestion feature already, and before that I added defines in the ESP32S3 repository. We are now able to compile for the ESP32 as well as for the PC. So this is just a test. And now I'm able to run the stuff on the PC because it's faster to implement. We can implement on the PC because it's faster, but then we have to test on the target. Very important. So we can't say it works on my machine. That's not a good idea. We have to develop on the PC. We can develop on the PC, but we have to make a final test on the target itself to ensure that everything is working there. So, okay. So these features are quite similar to each other because autocomplete and command suggestion need one base function, and that is the candidates. We have to define the candidates for the current input. For example, if we write dn, I have registered 2. I have to start the application, of course. We have 2. Oh, what is the state of the program at the moment? Okay, I think it's fine. So, let's say we type help. Then I've registered DNS hello and DNS test. And if I type dn and then I press tabulator, then I want to hopefully you see it. One tabulator means we want to autocomplete the command, and we have 2 candidates for D and N. 2 commands start with D and N. That is DNS hello and DNS test. And then for all candidates we have to check if all candidates have a common next character we can use. For example, in this case it would be S, because we have 2 times S, and we have no other character. So we can use S. We can definitely use S, but then we have H is different than T, and we have to stop there because we don't know if the user wants to write DNS hello or DNS test. So we can complete to DNS, but not further. So let's register another command. Let's call it, where is the registering? Come on, it's up here. So this is temporary, and we make another one called DNS test. So now we should have everything. So the compiling is way faster, and we don't have to flash the device. So the development will be faster. DNS, if I type DNS now, then we have 3 candidates, and here as well the command character is S, so we can at least add S to the string. So this means the candidates. And for the autocomplete we have while true. So we are working until we die. And we say this is our current index. Candidate end. we say P and next. We say here P and next is null. So what are we doing here? This block, the function of this block should be, we should change and insert. We should insert a lot of stuff. And the insertion is like, not history insert, but insert a character. Insert a character and do like this. No, not history insert. Sorry. Where is the insert? Insertion. Insert. Come on. No, that's wrong. History insert. Key process. Come on, key process. Data process. What the? Come on, data receive. So. Buffer edit. The function is called buffer edit. Yes, and here we have insertion. Okay. And in the insertion section, yes. Character remove. We have character remove. And actually, I want to see a character insert. So character remove. Character insert. Yes, nice. So, and here we have if the key is insert, then return character insert. Like this. And then we can reuse this function. If we have reached the end already, then return false. Then we have a cursor. We have a character insert and we insert at some position. That's okay. That's interesting. If I type apt and then I press tab, then the autocomplete is working. But so if I delete S and T and then press tab, then we have an auto complete. If we press tab again, then we have an command suggestion. But I want to see what is happening if I delete these two characters and then I navigate into the middle. Okay. Yes. That's more or less fine to me. What the hell? Dangerous. Dangerous. Ooh, very dangerous. Okay. Because then I have to activate my brain. And that is very dangerous. Okay. Because the index and is not that the candidates we want to get are not dependent on index call line and, but index call cursor. What if we press, now it's interesting, app test. What if we move into the app, press tab for one time, then it gets inserted, fine, but what if we press tab again? Okay, so the whole suggestion and autocomplete is dependent on the cursor and not on end of line. Okay, so this means we have to be able to move into the word. Okay, candidates get. We compare everything up to the index of the cursor. Okay, that's good. Then we create the list, that's fine. And then our index and is again not the line and, but the cursor itself. And then we are able to insert at this very position. Okay. Yes, okay. Let's try this again with the old code. DNS, I press one left and then I press tab, and then we have, yes, correctly, we have these candidates. Or if I press left again and I press tab, then we should have 4 candidates, because we have the D, and then we have 4 candidates which are starting with E. And here we can see that we have 1 E and then 3 N, so we can't go further in this case because there is one different character. So this is still working. Okay, cool, fine. Okay, let's go next. So we have something we want to add. We say bool okay is false. We just have bool okay, and then we say okay is equal to change insert p and next. P next. And if not okay, break. If not p next, break. All looks fine. So in this case we have to, this block has the function to find a p next we can use. We can check here if not index and then break. I think that's not break, but return. That's a special case, because if nothing is written into the command interface, then we can press tab and nothing is happening. We could make it, or let's say what is happening. App test. I remove this. That's interesting. Different behavior. That's a different behavior. If it's empty, then I don't want to have this behavior. I don't want to have this behavior. Let's say if tab process, if not cursor, then we don't do anything. For both cases, we can move this thing around. We should at least don't do it in a for loop, because it doesn't make any sense. So we have some index. We have a cursor, and that's our current index end. Let's check if this is working. Oh, it's compiling. DN and tab. Okay, that looks fine. Help, DN, and we have 3 candidates. That's okay. DNS test. So. So, at this point we should have a pnext. If yes, we have to go through all candidates. We have a certain p candidate and a pointer to the end character of the current candidate. That's fine. So we say next is pnext. Okay, so we say candidate and is some value. What the hell am I doing? So we have a certain character at the end of every candidate, and the next part we want to do is if not pnext, then pnext is equal to pcandidate and else continue. Otherwise we have a pnext, so we can remove this one. Yeah, fine. So if not next, then the next is the candidate and. Yep. And then if p candidate and is unequal to pnext, then we have one. Then we did not found the next. We have to reset next. and go out of the next is equal to yep. Hello Nick. Today is the last stream in which we are improving the command interface. The command interface got improved a lot. It's way better than before. We can move around, we can jump around, and we have a history. We have a cool history buffer. We can move around in the history, so that's very cool. And today we want to add 3 small but very important functions, and then we are absolutely happy with our command interface to the application. So, and this is the autocomplete feature, the command suggestion feature, and we want to be able to read and write memory. Because read memory is something we use very often. And yes. So, and we are quite far already with this feature. We have the autocomplete function. The autocomplete function, these two functions are quite similar because they need a certain base, and the base function is that we have to get the candidates, the command candidates for a certain input. For example, if I press D and N, then we have 3 possible commands, and if I press Tab, then we have 3 candidates, and then in the autocomplete function we have to check how far can we go, how many characters can we add until we encounter some difference in the commands, in the candidates, and until then we try to add a certain character. If we did not find a character, then we break, we go out of the endless while, and if we are not able to insert something, then we break again. So this should be quite promising. So the first feature could be finished, maybe. DN. Okay. Yes, I understand. Yes, because 2 things have to be done. The first thing is that we need to send a prompt, otherwise we don't see the result, because the top level thing is that we receive data, then we go through all bytes that we have received, and for every byte we put every byte in the ANSI filter. The ANSI filter, if the bytes have some escape sequences, then we try to get the final key. So this filter filters from byte to key, and then we have a certain key. The key may be an enter key. If we have an enter key, then we have to acknowledge the line and execute the command. Maybe we have to insert a history, but we then execute the command. If we have a tab, then we process the tab. Otherwise, we edit the buffer. And in the buffer edit case, we say if something has changed, then send the prompt. And these two special functions have to send the prompt manually. So this is the first thing we have to change. And the other thing is we see that there are a lot of S inserted, as we were able to see. So let's do it again. dn. Nothing seems... we can do it like here. Again, dn, and if I press tab, then the whole buffer is filled with S, because we have to move the end index. We have to increase the end index, and the end index should be incremented at this point, ++end, because dependent on the end index, we get the next candidate end, and then we can check again. If pNext is 0, then we set the new next, and then every other next candidate end has to match the next, otherwise we clear the next and then the condition is finished. So now we should see an immediate update of the prompt and hopefully a terminating condition. Oh yes. Oh yes. Oh, come on. So if I have D, then I press, let's type help. If I press D, then we have 4 candidates: the detailed function, DNS hello, DNS t, DNS test. So let's press D and then tab. We can't complete anything because the user might want to execute the command detailed, or the user might want to execute one of these functions. So we can't complete anything. So if we press tab again, then we have to should print the suggestions. That's the second tab. But the first tab is working already perfectly. But if we press N, then it can't be detailed anymore, but it can be one of these 3. And these 3 commands have this one next common character, which is S. But here we have a difference, H and T. And then we have to stop at this place. So if I press tab, then trying autocomplete, saving candidate DNS hello, DNS t, DNS test, and then the current candidate end is S, and it's always staying at S. So the next one is S, and we can insert. Then we make the next iteration. We increased the index of the end character, and then we try to read. Yes, an H, fine. So the candidate for the next character would be H, but then we encounter in the second command we have a T, so we have to break. We cannot insert anything else. So we break at this, we go through this condition. So we break, reset the next pointer. If we don't have a reset next pointer, then we go out of the endless while, and that's it. So the autocomplete command is finished already. Let's test something. I press dn test, dn something. Oh, no, not something. DNS foo, and then I should be able to move the cursor right next to the N, and then if I press N, we should be able to insert an S at this point. Mwah. Like the Linux version, everything is working as expected. App test. If we have in this directory we have two test scripts, app test and app test hello. If I press backspace 2 times and clear 2 characters and I press tab, then we have an autocomplete to app test. But if I go into the string and I press tab, then the command is completed from this point on, not from the end. It's inserted. The auto-completion is inserted. Okay, that's the behavior of Linux, and let's keep it that way. So let's see what we have changed. Yes, I changed something. Yes, oi. Buffer edit. Yes. System commanding. Add function add and use function character insert. So that's a good beginning for today. And then we add yeah, whatever. Let's add the whole stuff. So this is just temporary. Implement auto completion. Completion is correctly written. Hopefully. Whatever. I guess something looks strange to me. Okay. So the next thing is, I think that was the we knew trying autocomplete. We remove all the debugging stuff. Oh, I didn't push. That's perfect. So delete the log entries. That's fine. Okay, so this is working and everything is fine. Okay. Tab process. Now we just have this function left, printing suggestions, and this is hopefully a very easy one. Index call max, call command max is equal to 2. Index call command is equal to 0. And then we say go through all the candidates. Go through all the candidates. So that's easy because it's just printing. Yes. We should have some buffer out theoretically. Oh, come on. free. Yes, like this. Oh, free. We have a buffer out. We have a buffer out. Yes, yes. Buffer out. Yes, I think it's okay. I think we should print line by line. Yes, why not? Oh, and we have some spacing. Boah. Let's activate the brain again. Length of the buffer. We make it easy. We say character p buffer is equal to buff out, and we say p buff and is buff out plus size of buff out. And we say we clear the buffer. Yes. And then we use the d-info. Oh, one moment. We use a certain macro, a useful macro. Yes, I think this is it. Hopefully. Yep. Okay, so we have a certain buffer, and then we have an end of the buffer. This is the base address of the buffer and plus size of the buffer. Okay, then we have a start of the buffer, which is the buffer base address, and then we say we clear the buffer. Okay. Okay. It's quite hard. Okay, I want to print a command. Let's just say let's make it easy at first. Why not? I want just print the string of the candidate, and the candidate is called const character p candidate, which is the iterator. We print one command and then we print a new line immediately, and this should be sent. So we clear the buffer every time, and then we say transmit send of out and size is character pointer p buff start is equal to this thing. P buff, yep. P buffer minus the start. Yep, that's it, hopefully. So we have a buffer, we have a start of the buffer and an end of the buffer. And the current point of the buffer. And we reset the buffer at this point, and then we print something. And then we send this line immediately. Let's check if this makes sense. Yep. Pointer. Start of the buffer, and the length is the buffer we have printed. The current pointer is changed in this macro, and then minus the start. That's this the number of bytes, and then at the end we have to print the prompt again. So that's the first and easiest version. Unused variable, yes, okay. Interesting, should be an error. Should be an error. Why is this is not an error? Why is this not an error? Pfui. What the hell? Warnings. Yes, okay, fine. Nice, warnings, and warnings have args ++. Yep. Now if we compile, this thing should not be working. Unused variable, yep. Mason add all warnings. Yes. Whatever. Okay. Get diff. Yep. We add some temporary stuff. That is this one and this one. So now we can compile this thing and we can test this thing. Nope. Help DNS. Okay, so DNS. It got auto completed. Nice. We remove this log entries later. We press tab again. And something worse happened. Almost. So we have to add this thing and let's print the prompt. Let's print the prompt with no cursor no pre-new line, but the post new line. Let's see if this makes sense. So DNS, oh yes, look at that. We printed the current prompt without cursor, with no pre-new line, but a post-new line to here. And then we just printed the list of commands. But we want to have at least 2 columns of commands. Like here, app test. If I press tab again, then we have this list, and this list can be longer. And then we have looks like that. So we have 2 columns then, and this will be the call with, and then this looks nice. So this is not quite working, but we go through all candidates and we say the current command is this, and then we say if the index of the column index of the command is smaller than index call command max, then we say continue, and we say plus plus. So we are sending only in the case let's make it easier. Let's make it easier. String message. Let's make it easier. Keep it simple. Easy is fine. Okay. Yeah, I know. I understand why. Yeah. So we say command name size name command max is equal to, so this with call command is equal to, let's say 10. So fine. So we iterate through all candidates. We say message is equal to, we don't need this anymore. Message is equal to the iterator. Can we compile this? No, because we need a semicolon. Yes, that makes sense. That's now similar. C string and message dot size. Perfect. Unused variable, yes, of course. We say message is equal to message substring of 0 and this thing. We say message plus equal to rn. Okay, fine. So we try to make a substring and then we say message plus equal to if message dot size is smaller than this thing. With a name command. If this is smaller, then okay, but in any case we have to make a certain spacing. But if, then we say yeah. Oh, come on. Oh, boy. So let's check. We have a certain message. We have a certain candidate, and this candidate name goes into message. Then we make the substring of this thing. So if it's too long, then we make it shorter. If it is shorter than the max width, with name command max. If it's shorter, then we have to fill with spaces. We make spaces in any case. And then, Ishindo, hello Shrafi, how are you doing? Oh, it's working so nicely. So cool. It's so cool, I tell you. So we make a spacing for the first time. That's fine. If it's and then we do it again, and then we make a new line, and very important, we have to clear the index, and we should clear the index every time after the condition. We have a condition and we do something, and then if the condition is not met again, then we clear. Okay. So let's check this out. Let's see what is happening now. Help. DN. First tab is autocompletion. Second tab, DNS test. DNS test, but we should see every one of these. DNS hello, DNS test, DNS test. Why? Yes, of course, because we have to reset message as well. Yeah, let's do it like this. Whatever. Yeah. So as you can see, developing on the PC is way faster, but then we have to test it on the target DNS. Yeah. I don't understand. Iterator. Let's check this out. Proc info log message equals some string message C string. Yes, so DNS hello is fine, DNS test is strange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the DNS test should be so the filling is not working. What the substring, I guess I'm missing the substring again. C++ string substring. Substring, what is position and length? No. I don't understand. Yeah, okay. One. Let's make it. I want to have a fast solution. Easy debugging. DNS. So DNS hello. The first one is just the DNS hello. Fine. The second one is the substring of 0 and max. Because it's shorter than 10, it's not shorter. It's fine. The third one should have some value. The second one is fine. The third one should be longer. Maybe I have fucked up the string constructor. Constructor, how is the constructor? We need a character. It's always. I don't know how many times I get it wrong. First, we have to get the number of characters we need, and then I always exchange this thing. DNS. So yes, now it is working better. Yep, that's equal. That's cool. Fine. So this is working. This is working. This is working. But somehow we only get a DNS test. But it seems that this is sending something. No. What? Prompt. Yes. No, I don't get it. So we have this prompt. This prompt has no cursor. We are in the next line. We print some value. Yes. I understand. Damn it. Yeah. Okay. String. String. Okay. Message plus equal string. Oh yes, look. Okay, time for our next whiskey round. No, it's not working as intended because I want to, the max column is not working. As long as this thing is smaller, we go into this area. This variable is 0. Index colon command max. Yeah, no, this is just 1. This is just 1. Should we make 2 or 3 columns? At least this is too short. Oh, yes, let's make 2 columns. Yeah, 2 columns and even bigger. Let's say 25. Wow, so the command suggestion is ready as well. So this is the command suggestion thing. Yep, and we have candidates get. And we want to remove this line as well. Okay, so if we want to show this the candidates, command, yes, let's suggestions. So the command candidates show function first gets the list of all candidates, then it's sending the prompt again, making a new line, and then printing all the candidates, and then so fine, stop, help, we need this we have to see a second line again. So this is strange, it's not working because yes, I see because in the last iteration we have to send we have to send the last line, so message is not equal 0 at this point. We could write theoretically if message.size we can send again, but it's not beautiful. I think DNS still not working. Oh, come on. Because DNS we should see 3 commands: hello, t and test, but we don't see the last one. So let's think about it. We have 3 candidates. The first one goes through here. Then we get to the continue because the index call command is smaller than index marks. Okay, we take a second command, add it to the message. Then the call command is equal to this one, and then we add the new line and we send the new line. So we send two commands, this one and this one. We reset the index of the command and the message. We reset the message. Then we go to the third candidate. We go through this stuff. We add something to the message, but we don't add something. No new line. Oh, come on. So. And that's not beautiful. Maybe it's yeah, hello noch online. It's so cool. The command interface is so cool. Oh, look at that. Oh, nice. So we have auto completion and we have command suggestion. Oh yes. And then we can say, hey, test. It works perfectly. Oh. Everything is working so smoothly. I'm switching to German now. If someone is requesting English, then just type English. Oh, you should commit it. Ja, wird bald committed. Hast du einen Plan von IPv6? Das ist irgendwie das mit den Doppelpunkten, oder? Nein, tatsächlich eigentlich wenig. Ich weiß, dass es irgendwas mit Internetprotokoll zu tun hat. Und das ist, ich kann irgendwas pingen theoretisch. Aber codemäßig eigentlich kaum und auch nicht konzeptionell bin ich eigentlich nicht so hundertprozentig dabei. Leider. Also irgendwie ist das noch total an mir vorbeigegangen. Und irgendwie ist das schon ein bisschen überfällig. Also grundsätzlich funktioniert diese Funktion jetzt schon ziemlich geil. Wir sind heute fertig mit dem Improven vom Command Interface, wenn wir noch diesen Hexdump implementieren. Der Hexdump, den finde ich ziemlich wichtig. Den Write Memory werde ich noch nicht machen. Der Write Memory ist einfach, den möchte ich mir mal in Ruhe überlegen, den brauchen wir auch nicht so unbedingt jetzt. Aber den Hexdump brauchen wir für das Audioprozess. Wir versuchen ja Signalverarbeitung zu machen, Audiosignalverarbeitung auf dem ESP32. Und da brauchen wir auf jeden Fall das Read Memory oder den Hexdump. Nennen wir das einfach Hexdump. Gut, also auch sehr viel. Ich minimal, aber es hat ja ein NIC, einen Haufen IP, ich wusste, was ein NIC ist. Irgendein Network Interface Controller oder irgend sowas. NIC, einen Haufen IP-Adressen. Einmal eine IPv6, eine temporäre, ein was Local, ja genau, und noch ein paar andere. Der erste Teil, also Hälfte einer IPv6 ist der Präfix, den bekommt man vom Provider, ja genau. Aber welche der vielen IPv6 NIC-Adressen nimmt man für DNS-Aktualisierung? Für DNS-Aktualisierung. Boah. Muss tatsächlich gestehen, ich habe keinen Plan. Ja, das ist wirklich, Ich weiß nur, wie man, also die Link Local, die hat einen bestimmten Präfix. Und ja, den anderen Präfix bekommt man da irgendwie vom Provider. Aber, was da sonst abgeht, ehrlich, es ist echt bitter, aber ich muss passen. Es ist echt schlimm. Oh, wir haben da ein Häkchen vergessen. Das ist ein ganz wichtiges Ding. Weil mit IPv6 ist man von außen ja theoretisch direkt auf den Endgerät. Genau. Da brauchst keine keine, ich schätze, du meinst keine Ports, genau. Keine Ports weiterleiten, das braucht nur IPv4, genau, für einen Dienst. Hat dann einen Port und leitet den an die lokale IPv4. Genau, so ist es. Aber bei IPv6, ich habe es noch nicht rausbekommen, wie das genau und richtig funktioniert. Ja, ich meine, IPv6 hatte grundsätzlich auch verschiedene Ports, aber du brauchst diese Weiterleitung vom Router nicht mehr, glaube ich. Wobei, nee, ja, naja, ja, also ich muss sagen, ich check es nicht mal konzeptionell. Also es ist wirklich pervers. Also mein Know-how, was IPv6 anbelangt, ist sehr, sehr beschränkt. Ist peinlich, aber ich glaube auch, irgendwie kommt man direkt zum Endgerät, aber da sind auch diese ganzen DNS-Themen, das ist ja alles anders. Das ist komplett, komplett anders. Es soll einfacher sein, aber ich habe so lange gebraucht, ungefähr IPv4 zu verstehen. Und jetzt habe ich es so halbwegs intus und kommt IPv6 daher, das theoretisch einfacher sein soll. Aber irgendwie komme ich damit schlechter damit klar als wie mit IPv4. Das ist echt bitter. Äh, Funktion schaut schon ganz cool aus, nur dieser Teil gefällt mir nicht, dass wir das dupliziert haben, diese Zeilen. Das heißt, wir gehen durch alle Elemente durch und nur bei einer Newline senden wir das raus. Dann resetten wir diesen Spaltenindex und die Message, diese Line-Message, nennen wir das ein bisschen besser. String Candidate. Naja, da wird es halt ein bisschen, ja, das möchte ich vielleicht nicht. Aber hier sagen wir String Line, damit man sich ein bisschen besser auskennt. Oder auch nicht. Und die blöden IPv6 ändert sich auch ständig, jedenfalls die temporäre. Komischerweise die IPv6 vom Router, die ist immer die gleiche. Mhm. Wer kennt sich denn gut mit Netzwerk aus? Ja, komplizierte Kramme. Ich habe jetzt eine Cablebox, weil im Standard Vodafone Router keine Portweiterleitung gingen. Mhm. Ist drin. Hab öffentliche IPv4, muss also gehen. Kann man einstellen, aber Vodafone Router gibt nichts durch, obwohl es eingestellt ist. Und Vodafone bekommt man nicht hin. Das ist übel. Hatte also eine öffentliche IPv4, aber konnte sie nicht benutzen. Oh mein Gott. Ich hatte auch so ein ähnliches Thema. Bei uns ist es so, am Anfang war ich auf A1, da bekommt man einen Standard Modem-Router-Kombination und ich habe eine IPv4 und da wollte ich dieses Teil einstellen und habe angerufen und die haben gesagt, nein, nein, nix, pfui. Das wird nicht eingestellt. Und Vodafone, die checken das nicht, die bekommen das nicht gelöst. Ja, weißt du, was ich gemacht habe? Das war so geil, ich habe den Vertrag gekündigt mit A1 und bin zu einem anderen Anbieter gegangen. Dann habe ich gesagt, kann man dieses Gerät, das ihr mir schickt, auf den Modem-Only-Modus setzen, weil ich habe mir dann einen eigenen Router besorgt, wo ich dann das OpenWRT raufgetan habe. Und die haben gesagt, na klar, geht einwandfrei. Und dann warte ich eine Woche, bis dieses Gerät zu mir kommt und dann habe ich das identische Gerät, weil die nutzen die Infrastruktur von A1, habe ich das identische Gerät bekommen, nur freigeschaltet. Also da ist nur der Service anders. Also ziemlich geil. Ziemlich geil. Und ja, jetzt habe ich halt diesen ganzen Port-Weiterleitungsspaß da eingestellt. Aber ja, das ist... Ja, was heißt, die checken es nicht? Ich glaube, dass das so ähnlich ist wie bei A1, dass das Gerät für den Standardfall, für die meisten Leute funktioniert das und die sagen, hier bekommst du ein fix eingestelltes Gerät, das bekommst du und da wird nichts umkonfiguriert, auch wenn man es technisch könnte. Die sagen, du bekommst das Ding und wir geben dir für das einen Support, aber nichts mit rumdrehen. Ja, und also habe schon real Dual Stack IPv4 Port Forwarding geht jetzt. Aha, cool. Okay. Ja, das war auch immer ein Thema bei mir. Mann, ich hätte einen komplett neuen Router bei mir stehen. Total fancy Teil und ich müsste das irgendwann einmal in Betrieb nehmen, aber irgendwie, boah, ich müsste das unbedingt mal in Betrieb nehmen. Boah. Ja, dann bekomme ich schon wieder ein schlechtes Gewissen. So, was mache ich denn hier jetzt? Na, ich glaube, ich lasse es so. Ich lasse es so. Ja, es funktioniert und es ist fein. Da machen wir jetzt nicht mehr komisch. Wir, oh, wir machen da was Geiles und zwar zack. Nope, 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 yes. Oh. Rename Function. Ja, das wird gleich committed. Das wird gleich committed und ich finde es so geil, es geht schon so viel. Das ist ein Wahnsinn. Also diese Prozesse, die werden einfach von Tag zu Tag geiler und das macht immer mehr Freude. So, Split, yes, nope, nope, yes. Und da sagen wir, dann können wir nämlich wieder einen neuen Merge machen. System Commanding remove debug logs. Wie verhält sich das jetzt? Bekomme ich da jetzt irgendeine Meldung? Dürfte ich nicht mehr bekommen. Ja, cool. Oh, das ist so geil. TO. Und dann Uiuiui, was haben wir denn da gemacht? Gut, dass wir es noch getestet haben. Da haben wir noch ein Problemchen. Und wenn wir hier einen Kommando fast fertig haben, dann das Autocompletion. Dann haben wir einen Bug beim Autocompletion. Gut, dass ich das jetzt nochmal gecheckt habe. Und zwar, wenn wir wahrscheinlich am Ende sind, es gibt nur noch einen Kandidaten. Es gibt einen Kandidaten. Ja, genau. Es gibt nur noch einen Kandidaten. Weil wir haben Tab gedrückt, wenn wir hier sind und dann kann es nur noch einen Kandidaten geben und bei einem Kandidaten funktioniert es wahrscheinlich nicht. Wir bekommen hier einen Kandidaten, True, Next ist Null. Wir beginnen mit einem. Wir sagen, wenn nicht Next, dann sagen wir gut. Ja, genau. Vielen Dank, vielen Dank. Hat mich gefreut. Bis zum nächsten Mal. Wenn wir nur einen Kandidaten haben. Just one, we only have one candidate. What happens if we only have one candidate? So it seems we have a bug. when we have only one candidate, we go to the index end. We go through all candidates, which is just one. We check the candidate end is the last character. If the last character is not set, then we set the last character, continue. We say, okay, and then the index, the insert, I guess we cannot insert an empty key. Oh, yes, yes, the insert is... Yes, it gets written completely, it's fine. Ui. And we have to insert, the space as well. Ui. Because look, if we have app test and then we have hello, then as you can see, we get a space as well. Wow. That's hardcore. So if we just have one, that's hardcore. Ooh. So, but I guess we can add this already. So, implement candidates show. So I push GitHub feature. So you can check out the code. Come on. github.com, no orientation programming. Processing core. And then we say SystemCommanding. This is, no, that's the wrong one. So here you can see the current implementation. Of this file. So we have implemented the second feature, but we need to fix the auto-completion. Autocomplete. Autocomplete. We just have one candidate. We have a next. Fine. We have another next. Fine. Okay, we always have a next. Yes, we only have one next, so it's working. We have a next every time. Oh yes, okay. So I understand. If not p next, break. If nope. Yes. So if the next is I get it. If not p next, so if this is 0, if we have reached the end of a command, then we insert the space first. Actually, it doesn't matter if we can insert, it's just important at this point. Is it? I think so. Let's see, if this fails, then this fails as well. If this does not fail, I don't care, and if this fails, I make a break. Let's see. DNS test. Oh. I have a space. It seems that I have a space. As you can see, I have a space. I've got a space. But yes, this is okay. But then if not next, then we have to break. Yes. Let's see. Hopefully. DNS test. Oh. Interesting. Why do I have two spaces? Test. Yes, because I don't want to actually insert. I don't want to insert if not, yes. Yes, that's it. If not pin next, if not found, then I have to break immediately, but if not character of next, then I have to insert the last one. If it's working, okay. If not, then whatever, and I break in any case. Oh. Okay, that is interesting. I pressed tab again. Okay. Somehow this works more or less. Why do we have candidates show? We don't get any candidate. Yes, okay, nice. So we say if not candidates.size return. I don't want to make a new line at this point. Help DNS test. Okay. But that's fine. Oh yes. That's it. So and autocomplete if command full, command full, keine Ahnung, git add don't print new line after full command, whatever. So you're fine. GitHub feature. So let's see if we can compile this thing, EDF for the ESP32, ESP EDF would export. Come on, EDF pi build. So this should compile hopefully. Okay, so everything seems to be working. Add nodes tab. Okay, fine. So now, 9, almost 10 o'clock. Almost 10 o'clock. So, next step is to make an X at command suggestion. Behavior like Linux shell is fine. So that's quite cool already. So next one and the final one for today is the hex dump feature. So we do not follow the try principle. The try principle is try. Don't repeat yourself. We do not follow this. Don't repeat yourself principle. Yeah. And not approach the abstractions these abbreviations all the time. So sometimes I duplicate code if it is necessary, in my opinion, if it's necessary, and this is the case here, I think. Oh, come on. Components, core, common, lib, dspc, hex dump is a function we want to use, and hopefully I don't need this 2 hex string. We have a buff at this point. Yes, nice. Not cutting, just copying. And we add this function, command register help print, static function help print, hex dump, help print, hex dump, hex dump print. Yes, hex dump print. Oh yeah, that's a mess. That's a mess now. This is the function hex dump. That's the command. Then we have the function hex dump print, which is used by hex dump. And then we use this one. Blech. Pfui. Okay. Good enough. Good enough. We need a semicolon here. And we need some stuff here. So hex dump print prints the stuff of something. Like this. Oh yes. So we have a pbuff end, but it's not the buffer, it's something else. And this is fine to us. Fine for us. So. Okay, no, stop. We say here void. Hex dump. No, we don't say void, but we say void pointer p data is equal to. If we do not have an argument, p arguments, then we return. We say, but we say something. No content. No, specify address. Yes. Yes. Otherwise, we can say void pointer p data is equal to void pointer cast of strtool. Is this even some function? I don't know. Main audio processing register some command dummy calc str2l. Yes. So if not p arguments, specify address. Otherwise, try to make a long out of the arguments, because we know we have arguments. Yes, how long do we want this thing to be? Oh, come on. Hello world, main, fancy calculating, register, no, monitoring, register, process add, and we say, yes. If p arguments, then p arguments is equal to find the character in p args, this one. If we have this thing found, then size t len, yes, len is equal to 0. That's not beautiful. That's not beautiful. If p arguments, then p data is equal to this stuff null. Yeah, nice. Okay. Should we have a default length? Should we have a default length at this for this command? Why not? Let's say 32. And here we move this down and say if not p data, then okay. So that's better. P data null. If p arguments, then p data is string to long of arguments casted. If not p data, which is default null, then specify address return. If p arguments, then try to find space. If p arguments, then the length is string to long. P arguments null 10 10, and then we make a hex dump print of p buffer and p data len null 16. Yeah. Components common hex dump default is null and yes. So we say p name is default null and call width is default 10 hex. So we can say fine. Just print the hex dump of p data and length into the buffer as our answer for the command. And hex dump print should have a return value, which is processing string progress string size t because I want to progress string. We use a lot of the info stuff and then we return. Here we return, if not p data, then we return null, I guess. Yes, I think it's fine. Otherwise, we say here continue, blah blah blah, continue, and then we return buffer minus buffer start. Okay, fine. We need this as well. What? Buffer start is buffer. Then we change the buffer with the info macro, and then we see out. That's not cool. Buffer line. See out buffer line. Yeah, buffer line. That's not. Yeah, I know. See out. Do we have see out? That's not what we want. This is the buffer line. Then we say, ooh, that's not cool. Yes. Oh, my brain is hurting. My brain hurts. Actually, this is not cool. This is not cool. Hex dump, yes. The hex dump is limited. The hex dump is limited, I think, with the command execute. Yes, command execute, exactly. Command execute. We have a buffer of command size buff command out, a C size buff command out, and this buffer is sent to the function p arguments, and this is the range, but in the default configuration it's quite limited. 500, yeah, 500. Yeah, maybe. Hex dump. So hex dump, we say arguments, and the arguments must be the base address. Oh yeah, the base address. String to long. String to long. Is it possible to give this function a hex string? Oh, oh, that's cool. So we are able to, oh, that's a cool function. Long integer. Length. Yes, length must be size t, more or less. What's the return value? Long integer. Long integer. Yes, I think we have to say long integer. If len smaller than 0, then return. Ah, I don't need this. Ooh. Funk. Because we make an LF to CRLF. Oh, hex dump. So I have to reset this. Very important. Length must be length below 0, lower than 0. Okay, and here we have just n. And here we have just n. Okay. Buff line. buffer line. pbuff is pbuff start. Okay, we should print something that we can check. We should check the something useful. Something useful. The pointer of one of the entries. The pointer of one of the entries. In the process info function. Help print millis process info function. Init, come on, process info. We have the pointer, address of a certain line, of line 0. The pointer of line 0, the base pointer of line 0. Is some fancy value, and then let's check. Help. I have to register the command, of course. Register. Help is fine. I want to remove debugging register. I want to say detailed and colored is not important. Yes, detailed is important. Colored is not important. Nope, nope. Split, nope. Yes. Remove shortcut for command colored. So. Now we register a new command which is called hex dump, no shortcut, hex dump usage the address length is equal to 32. Ja. Oh, compiled. Okay. So, some fancy line, help. So we have a hex dump usage is HD, address and length. So let's just print copy HD Yeah. We have to register the correct command, of course. Yes. Command help print. Hex dump. Command hex dump. Hex dump print. Oh yes. What? Okay. So come on, help. So, and I want to see the content of the first line now. Oh, copy. Print. Oh, specify address. Come on, why? This is not true. That's a static function inf log. Command hex dump. Oh yes, it's working in general. So, do I need proc inf log? Inf log. Oh, I don't need a new line. P args is equal to S P args. Yeah. Did I miss something? Nope. Yes, the argument is fine, but the argument is fine, but I don't get something. I need something. Long int res is equal to ld res. Result is 0. Why? What did I do? Oh, no, come on. 16. 2. 0. Base. What is base? Base of 0. Starting from this again takes many possible from syntax that depends on the base parameter and interprets them as a numerical. Finally, if the value of base is 0, the syntax expression is similar of that of the integer constant, which is formed by succession of a sign character, an optional prefix in an octal hexagonal loop. Okay. Oh. Nice, but not working. And it's too long. It's way too long. Command hex dump null and 8. 8 is enough. Let's try. Let's check how it's looking. Do we need? Yes. I hope it's fine now. Length. Length is equal to 32 default. Yes, let's make it short. Let's make it 16. I just want 2 lines. So, come on. Now, help. HD. No. HD. Last time it was similar. Why this one? I don't get. How many bytes? The base address of 0 should be why we aren't printing the base address? Why? We are not seeing the base address, p data. We should be able to see the base address, but we are not seeing the base address. That's strange. Hex dump print. Oh yes. Ooh. Boah. Okay. I think this is fine. Yeah. Hopefully. Help. Oh yes. Mwah. Hex dump, base address, data, and offset. And hex data and interpretation. Oh yes. Mwah. Mwah. Cool. That's it. That's the whole magic. We need to specify an address. Okay, let's check the rest. What? I have removed all the debugging stuff. Fine. I go here. HD. Okay, HD, specify address, -1, length lower than 0, data 0. Must be greater length. Yeah. Okay. So remove DNS test hello. Okay. Help. Detailed help. Colored HD. HD off. Oh, come on. So fine. Fine. Must be greater than 0. Must be greater than 0. Just 1, 2, 3, 4, 5, 6, 7. Yes, that's okay. That's actually okay. More or less. Yep. It's good and good enough, I think. Okay. Something else. Length must be greater than 0. Yes. Default. Specify address. Specify address. What? Specify address. Yeah. Nice. Okay. Cool. Nice. So, all tests done. Info. No. Oh no. Wow. Process info. Address line 0. Yes. Get add. Partial. Split. Command help. Nope. Command help. Nope. 4. Damn it. Yes, yes. Add internal command HD hex dump. Yeah, okay. Help and HD. Yeah, help. HD. Detailed. Yeah. I think this is it. This is... Oh, okay. So finally we can clean all the stuff. Last command. Yeah, let's keep the last command. That's fine. Boah. Now we have finished a lot of stuff. Last command, state main. Okay, we do not need a state main. We just need a last command. Yes. Fine. Ah. No state, just the last command, no buffer. No logging. Fine. Clean up process info. Okay, nice. GitHub feature. So. Fine. Okay. Yes. Hex dump implemented. Autocomplete implemented. Command suggestion implemented. Behavior like Linux shell is a requirement. Okay, registering is will not be implemented at the moment. Efficient sending will not be implemented. No STL not implemented. Not implemented. Write memory not implemented. Yep. Yeah, cool. Okay, that's it. So. So. Now. Back to the roots. New commits, modified content. Fine. We go to what? What is happening? Ah. Oh. Yes, I understand. Okay, fine. Git checkout main. Okay. So we disabled this, and this, and this. Yeah, because, yes, I understand. Stash. Git stash drop. Fine. Diff. False, I understand. Uncommenting, debugging, understand. App, understand. App supervising CPP. perfect. Compiling and checking. Now we don't see the debugging process because we don't want to. We just see the main process, but we still have the command process, the debugging stuff activated, of course. So yeah, cool. So everything is is cool. So now git checkout main. Now we want to merge, but we do not want to have a fast forward merge, but we want to have a non-fast forward merge. So we say git n merge. Yeah, of course. So improved and dominating. Yep. Old functions, new functions. New functions. So new functions is autocomplete and command suggestion. And hex dump. New command hex dump. New functions, autocomplete, command suggestion, new command. New functions, old functions is append, command execution, navigation, line navigation, and this is history navigation. So every time we should be able to we should have all the base functions, the prior functions, and it should be better. It should be dominating better in every case. Okay, so now it looks like this. We have a feature branch, and the feature branch got merged into the main branch. We push GitHub main, fine, and then we can delete the feature branch. Branch delete feature git push delete GitHub feature. Nice. Okay, that's the core. That was the core. And now we have left update processing core. We can close the command. We can close the build for the PC. And we can build for the device now, and now we should test this, the whole stuff for the device. if everything is working as expected. It isn't. Why? Because we need an LX. Oh, nice, interesting. So we have to open again build native. Oh, nice. Pre like family include in types h. Core. Commanding. Constant format identifiers. Macros. Come on. What? What? Why? Everything is harmful these days. So come on. Print x in. Okay. Print x32. I guess. Address absolute. Let's see if this is working. Ninja. Expected. Should we do it like that? Nope. Because we have to int types, C int types. We have to include this, I think. Yes, and then build. Okay. Expect argument blah blah. But this is a different one because I have cast it to 8. Yep. Print x32. And here we have an 8 type. Wow, that was fast. Okay. Yep. Fine. No problem. Git add p. Yes. Fix hex the dump format strings. Commanding, closing, compiled for PC, compiled for yes. Okay. We can close. Let's say, I'm curious what is happening if, now this is interesting. What is happening if I say Ninja and then I press I want to print the content of a process. Actually, this is working. Interesting. Okay. Okay, so this is fine. Let's flash the device, and then after that we can. Okay, so today we have implemented and tested quite quite sufficient the commanding process. I think maybe it's not bug free, but it's good enough for now. So that's cool. And now I want to connect to the device. Hopefully this is still working. So 10. 0. Yes. Now you can connect to the device if you want. And check out. So let's see what kind of commands we have. Yes, we have on the ESP32 we have the assembler instructions like calc. Oh yes. That's so cool. Oh yes. Nice. That's so that's so much fun. Okay. So next time. Next time, yes. Depending. I have prepared a certain. So we can close this topic. I think we have implemented the jump, the auto completion, the static. No, yes, this is interesting. Features. New, old, commands. Append commands, command execution, navigation, insertion, deletion, history, insertion, navigation, buff, autocomplete command suggestion, modes, auto interactive. Not possible because of putty. Yes. Write memory not implemented, message podcast neither. Okay, so yes, we have to. That's it. Oh, that's one thing. Because we want to check if this is working for these environments. That's very important because we have implemented everything, but now we want to check if this is working for every target, at least building. Update. You can you should be able to connect to the target with telnet Nigolus testing USTO 2000. Yes, nice, it's working. So now you can connect to the device and test all the channels if you want. This is the command interface, that's the logger, and that's the last one is the process tree. So you can just press H and E and then tab, and then we have help and calc. We should be able to jump, delete, command not found if it's not found, yes. That's interesting. If we jump, then we jump here. Oh, someone switched the detailed state, I think. So everyone should be able to do stuff. Cool. That's nice. That's cool. Yeah. And yes, I prepared the a repository which is called processing build test, and with the help of Coder2K, shout out to Coder2K, he gave me his, he has a certain repository, Coder2K sockets. He is at the moment working on a socket repository. The backseating committee. Yes, this is the repository, and this repository is an implementation, a wrapper for sockets, and it's using modern C++, and you can walk through the code and detail. I think most of the stuff is implemented here, I guess. So it's using modern C in general, but he gave me his, or showed me his continuous integration YAML file, YAML, whatever. And this file is used to for testing on GitHub, you can, if you have defined such a file as we did here in GitHub Workflows. We did this for the build test, and here I have a similar test, a little bit different, but quite similar. And we are testing on Linux and Windows, and we tried to compile this repository, and this repository will contain, should contain everything from core and common in general. So at first we want to be sure that everything is compiling and running on everything that is on the core. And if we change something, then we should be able to check if everything is compiling flawlessly. So let's see. We have the last 7 minutes. We will improve this script in the last 7 minutes. The build test. So now we have a core. We update the stuff. We don't have this anymore. Git merge origin main. Git remote rename origin GitHub. Git checkout review. Git merge main. Git push GitHub review. Come on. Git remote. Components core git remote verbose. So copy. Git remote remove GitHub. Git remote add GitHub. Yes, nice. Git push GitHub review. Nice. Perfect. Okay. So updated. Git go update processing core. So the build directory is updated. So is this thing bricked already? No, it's still working. Fine. So we want to check if we can cross compile this stuff for whatever. Let's see, Mason build. Yes, for Windows 2 did we install MinGW already? MinGW installed already. Yes, nice. Not installed or updating. Okay. Nice. Updating, hopefully. So at least we have the toolchain for the Raspberry Pi now, and we should be able to compile this main for, that's a main without processes. Oh, Negwasa, hi. Hi Negwasa. we have finished our commanding process. So now we have an absolutely cool connection to our application. We can do a lot of stuff now. We have implemented all these cool features. Look at that. That's cool. It's working everything as expected. And we are very happy. We can, at the beginning we had append, just append. If we tried to navigate, then we got strange characters in the console and in the command prompt, and we were able to, we had a help and some dummy functions, a command execution, but now we have a hex dump command and navigation, line navigation. Yeah, autocomplete is nice. Autocomplete is very nice. Line navigation. You can check out the code here. It's merged already. So I'm always merging if everything is working better than before or equal. Then this is the repo and the code is in SystemCommanding. The file is too big. It has 1600 lines. It's too big in general, but we will keep it that way. It's a jumbo file. It was created in November 2019. So this file makes us happy since 2019. And it's when COVID started, approximately. But now it brings us even greater joy, because now we have the two best features for me are not the history is cool, the navigation is cool, everything is cool, because the line navigation is very important. If you have you can connect if you want. You can check out the result, neckforcer, here. You can connect to the command interface. The first one is the process tree, the second one is the log, and the third one is the command interface. And in the command interface you can now type help, for example, then you can press H and E and then tab, and it gets auto-completed. If you press for example just H, and if you press a tab 2 times, then you get a list of similar commands. That's cool. And we can, if we have an error, we can replace it. If it's not known, then it's not known. Otherwise we get some result. Yeah, that's cool. That's so this we theoretically we could implement even more, but at this point I would stop, because we don't want to implement an operating system. It's very important to understand. For me, there is no such thing as an operating system. Every software should have a set of processes, but we can decide how far what we implement. We could implement the execution of processes. We could implement the feature to set processes in the background and have jobs and stuff like that, and file system and stuff, and then we are slowly getting to an operating system. But we just have an application, and this application just needs some stuff: the focus, of the processes is just the function of the application. And the command interface should be only as much as should be as powerful as needed, but not beyond that point. So but that's just my opinion. That's just my opinion. That's not that is no truth or something. So yes, the hex dump feature is very important for me because length. I betrayed myself. Damn it. Okay. Yeah. So again, we have build test. Okay, one moment. So we have express EDF export sh and now native ninja. Okay, fine. One problem is that we is equal to 32. I said that the default of length is 32, but actually I think it's 16, so we should make a constant. And we should call it const long int c len hex hd hex dump len of what? Length of hex dump. Len hex dump is the standard. Yeah, like that. Fine. So okay. Stop member functions, mutex and constants. Fine. And here we should I'm not yet ready. I'm not yet ready. As long as it's compiling, it's fine for me at the moment. I'm too lazy. Change something. So okay. Did I do something wrong? Let's see. Maybe I was too fast. Core. Yes. Okay, now fine. So we have changed to 16. and it's actually 16. So check out main git merge main. So fine, okay. Nope. So build, and the thing we want to do next is in the next stream we will we will code on the ESP32, because I will, depending on what you want to see. The current project is at the moment. And Nick Wasser, you can check out our different project at Telnet Naegulus USTO. Here we have a gaming server implemented with the same process system, and here we can play Connect 4 at the moment. And that's quite cool. If you want to play, we can play around. The uptime is 3 months already, so it seems to be quite stable. Or let's see if I can connect with my user account. Still. I'm not sure. Oh, cool, yes. Oh, Gamer Nagelus. And I can go to the user settings. Nice. Everything is working still. Now I have a greeting. Cool. Oh, that's so nice. Cool. Yes, that's our main project, and the current project is to implement audio processing on the ESP32, and before that we should theoretically make a test of our current core system with the help of our build script, test script, whatever. Okay. But I think we will do this in the next session. We can decide which one we need. You can always check out our Discord and tell us what you want to see. The Putzler. Let's rate the Putzler. Yes, let's rate the Putzler. Oh, he's doing keycard stuff. Thanks for watching. See you next time. Next time is on Thursday. And yeah, cool session today. See you on Thursday. Bye. So and let's rate the Brutzler. Cool guy. He's coding, or we can't rate. So we can rate someone else, or we will rate next time, because I have to do something else today. Then